Well, we are going to just have an introduction to my book, The Paradox of Information Loss Problem and Possible Resolution. So you can see it, the paradox of information loss problem and possible resolution. So what I'm going to just give you a sort of introductory summary, sort of what this topic is. First of all, this information loss paradox, it's a very old and fascinating problem, maybe more than 50 years. And it's basically, it deals with one of the very interesting and maybe interesting, partially solved, unsolved, depends. So how people have addressed, and it's very active and engaging endeavor of not only physicists, scientists, theoreticians, and maybe people who work in the observational aspects of how they try to see these very compact and dense objects, or very singular objects, if the mathematical word is more fine, called black holes. So the puzzle goes like this: if you have a black hole in that sense, and in that black hole, and there is some observer who is outside sitting, and an information bit gets it goes into this black hole. What actually happens to this information bit in that sense? So it's a very sort of puzzling in the sense, because this very question has engaged physicists or theoreticians pretty long time, and particularly the way Stephen Hawking famously formulated this question, in the sense that black holes are not the objects in the conventional sense of the word. It's not that black holes are going to swallow or absorb all sorts of information or things into it, but black holes also emit at a quantum level at some stage, which what I should say contradicts, or which is counterintuitive in some sense, that there is black holes also emit. So it's not that black holes take all the information inside and they just swallow it without any trace of it, but they also emit that radiation. But the precise formulation of this question, exactly what happens to the information bit when it enters into black hole, it has engaged physicists in a very long manner. So this is a sort of a prelude which I am giving to basically my sort of how I have tried to address this very question in this very book, The Paradox of Information Loss Problem and Possible Resolution. So if you go to the etymology of this thing, so paradox of information, so I have missed the word loss, information loss. So this is a paradox. Now the thing is that if it's paradox, so paradox can be seen as from a given vantage point, there can be maybe one or more answers to a given question, and they may agree, but when these questions may have different answers, but when seen from different perspectives, they may come to some common point when you can see. So since the paradox is there, so you can translate the paradox has been more a sort of problem in some literature, as if it needs to be solved. And there come this thing called possible, not one resolutions. So in my understanding, many resolutions. So what are the resolutions which I have covered in this book, or which you can surf through the literature? They are wide and far in that sense, and they also depend upon the individual subjectivities of researchers, as well as current state of our ignorance or knowledge, in whatever way you want to state this problem or this solution to it. So the broadly you can say, once an information enters into the traditional conventional way of looking at it, is it the black hole. The definition of black hole means, so nothing comes out of the black hole and it's lost, or after some correlation with the external environment, the information gets back from where you started. Or there can be the information is not lost, it comes up in some another manner, in some in a correlative, in a non-trivial way, in another way. So there are, if I just maybe for the flavor of this introduction to just maybe summary of my this thing. So there can be, so if you go stir, there can be remnants, there can be what I should say. So there are huge sort of there can be very various ways in which people have tried to bifurcate it or classify how actually happens to what actually happens to information bit which is outside. It's not only, so if two observers, in Alice or Bob or any two observers who are sitting outside the black hole, something goes inside that black hole. So how are they going to measure or observe? So should the two measurements by these two observers they will agree on their measurement or not? So an information which enters the inside this event horizon, the traditional definition of event horizon, and once it enters, so if an information bit comes out from outside the black hole and there is an observer, for the sake of argument, inside, so should that bit reach here or not? Or if two observers are sitting outside, so should they emerge, should they see the fate of information in a unique way or in a standard way? Should they agree to the fate of that information bit? So these questions have different answers. So traditionally there is something called a paradigm called black hole complementary means so observers should not be able to just distinguish the interior and the exterior of the black hole in some it should not be able to, the distinguishability should not be there. So this principle has been very much significant in the early formative years, how this subject evolved. And maybe there's another something called black hole membrane paradigm. So means we can assume so if one is taking black hole as a clean mathematical and theoretical construct, but other is taking a black hole, the membrane of the black hole, having some physicality attached to it, some physical properties, like we can imagine elasticity, tension, and other things. We can see these things. So you can say there's a lot of debates which are going on and which have been there, starting whether this information is stored in the membrane in the outside, or the information just in the minute correlation of black hole with the rest of the universe, or black hole with white hole, or black hole somehow dumps the information in a topologically connected universe or multiverse. So there can be theoretical speculations bordering on many assumptions, and in that sense, and they have to be seen how we fundamentally try to see QFT as a fundamental theory, GTR or general theory of relativity, how their extrapolation towards the interior, these two theories towards some particular sense, how one will extrapolate that understanding in the interior of black holes or these strong compact objects of in principle infinite mass, how these theories pan out. Are there some limits to these fundamental theories where we can somehow make them come or extrapolate them, or towards some backwards, or forwards in that sense. So what makes this black hole information paradox interesting is that it if we try to, in the sense that if we can understand this mystery, we can also understand how the universe started. So the end of black holes means the end of stars. So you can say, in at least conceptual and mathematical formulation of trying to understand black hole, it's like hydrogen atom of the universe, if I quote one physicist. So what sort of solutions do physicists they just are trying to just see to this thing is that we can have resolutions. So we have talked a bit about problem. The problem also stems from this fact that if in the presence of a black hole, an entangled pair of radiation is getting produced, and sort of polarization takes place, and one part of radiation goes inside, and we don't know what the other, it's the entangled counterpart, how can relate it. So it has resulted in a flurry of debates and exchange among physicists, where this solution of this black hole information loss paradox, it has maybe there are attempts from semi-classical analysis. There are theories like string theory, which has said to say something about how we can approach this thing. There are frameworks like firewalls. This is not a framework, but it's how the information bit which it enters here. So how does a black hole? So it will not enter straight away. It will not enter without a drama. This bit, something will happen at the event horizon if a black hole enters here. So there are fuzzballs. Fuzzballs don't assume a center of black hole in that conventional or traditional sense, but the interior is somehow non-trivial in a geometrical sense, connected to the exterior of the. In that sense, there is no so in the black. So it somehow there's something called fuzzball complementarity. So it just fuzzball has a way of trying to in this way trying to see how we can see. So there are fuzzballs and there is firewalls, and maybe there is something called non-violent non-locality. So it is also one of the. So maybe the way we have local way, Lorentz way of two points in space, so they can communicate with each other within the bound velocity of bound is maintained there. But if there is a non-local way of seeing things, so maybe these two information bits, if they go part of that entangled pair, so how can we relate the interior or the exterior of the black hole? So if we can relate them in a non-local way, not in the local manner. So we don't take the conventional quantum mechanics, we can take a non-local quantum mechanics, and the way we can incorporate the principles of Lorentz invariance, locality, and so on and so forth. So there can also be maybe there's like just like string theory, there is also loop quantum gravity, and there are debates of quantum information theory. Quantum information theory, maybe people from computer science, people from physicists. So they know what two bits of information how they communicate, or there's something called a sort of cryptosis, how we can encrypt or decrypt a message between two or more participants in a given group. But here the decryption is between if two observers are observing to their loss something information. So should the two observers agree to the what happens ultimately to the that information bit in the estimation of two observers, how do they decrypt in that sense? Or there is something called apart from this thing, so we can also have Entanglement, and something you might have heard in things, something called EP is equal to EPR. So, or gravity is equal to quantum, to use one of the physicists in that context. How we can, how in a non-local manner, how not only two black holes or two copies of black holes, how they can relate in a way, but two universes, two wormholes or multi-universes, so how they can connect to each other, such that if information or communication is there, it happens in a non-local way. So we can uh, see the mimic, the fate of not only observation, but also how fate of not only information bit, but how two black holes or two wormholes, how they are going to connect in some non-trivial manner. And maybe there are very so since the one important point and other something like in string theory, something we have something called holography, where we connect two theories, one ADS theory, other the CFT theory, and if you just connect them, we can recover information in a very subtle way, at least in the theoretical sense of the word. And it's this entire thing, these theoretical constructions, how we can basically ultimately relate them with the experimental parts of the observational astronomy in that sense. So the way the astrophysical black holes are there in the universe, so can we have we been able to connect this thing with how we can measure this Hawking radiation. So far, maybe astrophysical evidence has been lacking, or the way the magnitude of this radiation is too small that sometimes the calculation, so it may be drowned in the CMB. So even though we have robust and theoretical reasons, calculation reasons to believe in the Hawking radiation, the experimental difficulties or surmountable difficulties have been huge in trying to just reach out or detect this Hawking radiation. So whatever I have said, so the thing is that basically I want to somehow the book which I have written, the paradox of information loss paradigm and possible resolution. So you can find all these discussions in an up-to-date, in a state-of-art manner. What's the current state of knowledge, and how people have observed or how people are engaging with this question in a fundamental way from last 40, 50 years, and how not only in a retrospective sense but also in a prospective manner, how people have been trying to see things. And maybe with a couple of maybe a huge part of it is how people have taken, but I have also added how annotations are there in here and there, where I have also tried to give my point of view in that sense. So apart from surveying the different perspectives, I have also tried to see whether this information loss problem can be an ideal testing ground from the quantum gravity, as well as connecting in some empirical manner, as well as in the observational astronomy, observational part of things. And one thing is there, I have also tried, which is not normally found in books. I have tried to see or literature. So I have also tried to connect this information loss problem with the scientific method in that sense. So we have included the Popper's verification principle slash Russell's one is truth conducting, and other is truth affirming principle. So I have seen this information loss problem. If there is an impending need to observe something and we are not able to observe things because of the limitations of experimentation, should it say something about how we can see it in the fundamental scientific paradigm? So there way I have tried to connect this question in that sense. So this is my motivation was to just people should just try to see this, and in that context just I'm strongly recommending my book. So people say self-praise has no recommendation, maybe, but I feel that I'm recommending it, and if you go through it, maybe you will get something. If not, if you will not understand the entire of it, but definitely you will get something is for you, which will satiate your curiosity, or which will like it in some sense. Thanks for listening. Thanks.